limits graphically. Sometimes this throws students off, so I wanted to do something like this where there are no numbers. There's just letters. So that, math teachers for centuries have been hearing objections to why we put numbers in with, or letters in with numbers. There's constant. It's like a guarantee every year at open house that there's going to be at least one parent that tells me they were good at math till they started putting letters in it. It can be more confusing sometimes whenever you got to deal with this like theoretical where there's these letters instead of numbers. So in order for a limit to exist, the limit from the right and the limit from the left have to be the same. So what I like to think of, wherever your x is approaching, I think about putting a vertical line right there, a little dotted vertical line. And that's the line we're getting closer to, right? So if I look at this first limit, I've got the limit as x approaches a from the left. So I will start over here on the left side. I will follow the path of that graph until I hit my dotted line. It does not matter here whether it's an open circle, closed circle, there, or if the line just continues, right? We just stop when we get to that dotted line. So once you do that, you are reporting the y value as your answer there. So the y value of that point right there as I approach from the left is C. If I do that same thing but I come from the right side, I'll follow my graph over here until I hit that dotted line. Here I've got an open circle, but it does not matter for limits, right? If I'm finding f of something, it matters, but if for limits, it does not. So for limits, it does not matter that that's open. Obviously, I hand drew this, and it's not perfect. It should be right there on the line. And I'm going to go right here, and I'm going to report the y value that goes with that point. So that, in this case, is B. Now, in order for you to have a limit at that x value, the limit from the right and the limit from the left have to meet. Right? So, in this case, they do not. Right? We've got limits that don't meet up. So if we have a jump in the graph like that, the limit does not exist at that jump. It's C from one side, B from the other. So from both sides, this would be does not exist. All right. So visually, when you're looking at these, anytime you see a jump in the graph, or if we have like a vertical asymptote, any place you've got a jump in the graph, you are not going to have a limit at that particular point, at that x value. Now, over here, on this side, if I put my dotted line here, this graph is not defined at A. If I were to ask you, I didn't, but if I asked you for f of A, it would be undefined. And it is undefined because you've got a hole in the graph there. That hole tells us we're not including this one point, right? That happens a lot of times when you got something that's going to make the denominator of a fraction 0. You get just one little hole in the graph. So this is going to be undefined at that point, but that doesn't matter for limits, right? So if we look at this, as we approach that line from the left, we go to this point right here. So we will look over here to the y-axis. That y-coordinate is B. The same thing is going to happen from the right side. We go to that same point. Y-coordinate is B. So since our limit from the left and limit from the right are the same, we would also have a limit of B for the limit as x approaches A of f of x. Okay, questions on that? Now, neither one of these here are what we would call continuous. Continuous is like you can trace it with your pencil without picking it up. because you've got this hole right here in the graph. So it's not continuous, and we'll talk more about continuity and how to like prove it officially later. But these are not continuous. But over here for this one, although it's not continuous, it does still have a limit that exists at that point. Okay? And then it just reiterates that the actual value of the function at a given point does not have to match the limit. So if I look here, I'm looking at the limit as x approaches p of f of x. So if I'm thinking about that dotted line again, x approaches p, so that means vertical line where x equals p. So when I look at that, Cade, what is the limit as x approaches p going to be for that particular graph?
R.
It's going to be r, right? I'm going from both sides. I go to this point right here. Y coordinate there is r. Okay? But, Zach, what is f of p? It is q. Because where I actually have my colored in dot is up here, right? So it's defined as that q at that point. This is not continuous, but the limit does still exist. Okay? Questions? Okay, this particular one has a vertical asymptote on it. For the graphs that I give you, if you have something that kind of looks like it is going to be an asymptote, assume that I meant for it to be an asymptote, right? So right here, I do intend right here for this to be a vertical asymptote. My hand-drawn graphs are not great sometimes, so forgive me that that's a little off-centered on that line, but I do intend for this to be a vertical asymptote. Okay, so let's just go through. Let's see. Sarita, what is f of a going to be? It is 0. Very good. So you're just looking closed dot right there at A. Y coordinate of it would be 0 because it's on the axis there. Let's see. Maddox, what about f of b? Perfect. Okay, because you've got an asymptote right there. There is no closed-in dot or solid line, right? So that would be undefined at that point. And remember, f of something, that's undefined. Limits do not exist, that for our terminology. Let's see. Raven, what about f of 0? It is g. Wonderful. We're looking at this point right here, that colored in dot. Because when we're looking at f of something, we care about where it's colored in or solid. X coordinate right there is 0. Y coordinate is g. Okay. Braden, what about limit as x approaches 0 of f of x? Are you sure? 0 is right here. It's the y-axis, right? Okay. It's going to be f. It does not matter there that you've got an open circle, because you go to that same point, right? So when we're approaching that y-axis, from the left side you go to this point, from the right side you go to that same point, so the y-coordinate of that point is your limit. Okay, questions so far? Connor, what's 5 going to be? Limit as x approaches a from the right of f of x. It is also f. Because if we look right here, from the right, we approach. Did I say left earlier? I might have said that wrong. If you approach from the right here, you're going to end up at this point. Y coordinate of that is f. Okay. Let's see. Bo, what about limit as x approaches a of f of x? Does not exist. Wonderful. I'm going to just put D and E for space and time. I don't mind you abbreviating things. Just make sure when you write D and E in your head, you're saying does not exist. Because otherwise you end up with acronyms that you don't know what they mean. And that is not good. Because like on AP exam, if it's multiple choice and there's a limit that does not exist, they're not going to put D and E. They're going to put does not exist. So you don't want it to become like there's lots of acronyms that probably don't know what they mean. Or some of you may, but like NASA, SCUBA is an acronym. I don't know what SCUBA stands for. but it's an acronym. It stands for something. I don't know what it is. But nobody ever really lists out whatever scuba stands for. They just say scuba, right? And we know what they're talking about. So you don't want it to become that. Limit as x approaches b of f of x. Okay? What do you think, Wesley? Okay, that is a very good and acceptable answer. But there is a more specific answer that we can give. What do you think? You can also say infinity here. Okay? Now, technically, limits that approach infinity, or limits that equal infinity, technically do not exist. Because think of what the word limit means. If you go down 77, there's a speed limit sign, and it says 70 on it. What does that mean? You got to stop. You can't go any faster than 70. I mean, we all know in reality, it's more like 75, 76, 77, somewhere in there. But definitely don't want to hit 80 or above. You're putting yourself at risk there. But legally, technically, if you go 71, you're breaking the law, right? 70 is where it stops. That is a limit. If you go down 77 and you see a speed limit sign that says speed limit infinity, is that a limit? No, you can go as fast as you want, all right? Now, some of you teenage boy drivers probably feel like it's infinity sometimes, but I dread my boys getting licensed, especially the oldest one. My youngest one's a little cautious. The oldest one is not. It's been a challenge to keep him alive. It's 11 years. So technically, if the answer is infinity, it does not exist. So you could put either answer here, because from both sides you do go up to infinity right here. So what you will see with these is if it's something that you're writing out the answer, I will accept either or both answers. But you'll probably more than likely see it on multiple choice, and both of them will not be there. So it might if it does not exist, there will be no infinity there. If it has infinity, does not exist, will not be there. Okay? Limit as x approaches c of f of x. Sarita, what will we get for that one? Very good. That'll be 0, right? Because we're looking right here at c. There's no dots here, but you just go to that point, that solid line, and it has a y-coordinate of 0. And then, let's see, Hallie, what about the last one? Limit as x approaches d from the left of f of x. Very good. It is z. Okay, questions?